All right. Well, thanks for being here. It's a pleasure, a great pleasure to talk to developers. My name is Venkat Subramaniam. I'm here to talk about one of the things we deal with every single day of our work, which is this conflict between our desire to make things simple and how the world around us continuously seems to get complex. I was on a flight. I travel a lot, but on one of the flights, I was next to a guy. And he said, what I do for a living. I said, I'm a programmer. And immediately he said, with a bright smile, he said, that's the easiest job on earth. I said, that's great to know somebody thinks like that, but can you tell me why? And he said, well, all you have to know is zeros and ones. I said, nah, that's pretty cool. And I said, but do you know why they pay us the big price they pay? I said, why? I said, because only we know in what order to put them together. And that's where the complexity really relies in. How do we really work with the problems, the domains? And software is being used today in almost any form of human activity. It's absolutely phenomenal how much it touches our lives. So how do we deal with all these things we do? Well, in this room, I would say there's probably one of the most complex things ever. That is our human brain. But if you look at the human brain, it's pretty fascinating. We would associate terms like creativity, absolutely phenomenal ingenuity when it comes to human brain. But the human brain also gets pretty tangled up with emotions. We get confused. We cannot see clearly solutions. And then we kind of wake up and say, duh, why was this so hard? This is kind of obvious. We say hindsight is 20/20. There are times we struggle with problems for hours, if not days. And then when the solution comes up, we are kind of surprised why it took us so much effort to really figure this out, and all these complexities we got tangled into and the confusions that arise from it. Well, I often talk with my children about Schrodinger and Schrodinger's cat. It really keeps kids excited when you talk about these stuff. A lot of times the conversation would be, one of my kids would text me saying, that's like a Schrodinger's cat. Well, Schrodinger once had a thought experiment. He said, if you put a cat into a box and you can't see through it, you can't hear, and if there's a vial in the particular box, at any given time, he said, a cat may be both alive or dead. How do you really conceptualize some of these ideas? Things become really weird at some point. But one of the things we have to constantly confront with is complexity in our daily lives of programming. But Confucius said, life is really simple, but we insist on making it complicated. That is so true, though. And we deal with this every single day. We want to take things, and how do we really deal with complexity, and how do we make things really simple? But why are we really interested in insisting on making things really complex? And so I like the why question a lot. I want to know why we do this. And I'll tell you why we actually do this. We do this because it really feels good when you make things complex, isn't it? Because when you make things complex, you feel like what you have done is important. You feel there's credibility to what you do. And if you do something that's really, really simple, you're worried that maybe people won't value it. You go to a colleague and say, look, here's a design I created. What do you think about it? And your colleague looks at it and says, yeah, that's simple, I understand. You feel a little let down. You say, I'll come back tomorrow, and you make it more complex, probably. Or there's another benefit of making things really complex. It gives us job security. Because when it comes time to lay off, the company says, what do you do? Don't touch Joe, because nobody understands what he is doing. So we tend to really have that cloud of this job security as well around us. And so there are a lot of reasons why we kind of get tempted to make things really complex. But the problem really is, Einstein really nailed it. He said, any intelligent fool can make things bigger, more complex, and more violent, but it takes a touch of genius and courage to go in the opposite direction. I want to outline the word that he said, courage. And this is one of the things that I find more and more important, is to have that real courage. Because when you're sitting in your meetings, when you're sitting among your colleagues, when you say something that's really simple, we often get ridiculed about it. And to have that courage to say, no, I really want to think about this further, because we don't need to deal with all that clutter and complexity, and that really takes perseverance and courage to be able to stand up and say, we want to really create something simple, and that's one of the reasons why he really uses really brightly the word courage. That's very important. But the question is, if simplicity was sitting next to you on a train, would you even recognize it? Would we even look around and say, oh, you are Mr. Simplicity, aren't you? Would we be able to even recognize it? And that is one of the challenges is, when you work with people, it's not very clear what simple really is. I had an experience actually working here in Poland with the team, and I was endlessly complaining that a piece of code was really complex. And after several minutes of quietly putting up with me, one of the developers finally said, I don't get it. You keep saying this code is complex, but we all think it's simple. And I said, oh, wow, wait a minute. You all think the code is simple, but I'm thinking it's complex. But explain to me why you think it is simple. And the gentleman said, well, all we have is a very simple for loop in this, a very simple if statement in this code. Why are you so upset about it? And that's when I realized that we don't understand what really simple means, because that if statement was duplicated about 60 times in this function. And every few days, they would have to come and add more if conditions to this code. And this was duplicated in several places, increasing the complexity of the code. So a lot of times we use the word simple, but it is very difficult to define what it is. Here is an experiment you can really try in a nice way. You can go to work and ask your colleagues, hey, what is simple? I bet you'll get as many answers as the number of people that you actually ask, but nobody can really put it into really good words, because simple is something we all kind of feel, but we can't quite gravitate towards and define it very easily. So how do I go about defining what simple really is? Well, like I said, it's really hard to define what simple is. So I'll take an opposite attempt. I'll try to explain what simple is not. And maybe if we can understand what simple is not, maybe we can avoid those, and maybe with a good hope, end up with what's simple. So I'll talk about what is not really simple. How about that? So I want to start with a few things that I believe are really not simple, and we can avoid them. The first and foremost, simple is not clever. Now, how many of you have ever written clever code? Come on, be honest. Yeah, everybody here has done it. Some of us have the courage to raise the hand. Others are like too embarrassed to raise the hand, right? So we all write clever code. Why? Because we have pride in what we do. We want to write something and stand up and say, man, wasn't that cool the way I wrote it? Well, I remember an experience not too far back in time. A client asked me to fix something. And I looked at the problem and I said, oh, I could fix this in 10 minutes. But oh no, I don't want to fix this problem. I want to fix the mother of all problems. I want to fix problems like this, the patterns of problems that could happen like this. And so I spent an hour writing a very clever solution. And in all honesty, I felt so proud about it, so proud that my body literally detached from me and came and hugged me because there was nobody in the room to celebrate this. It felt that good. And I went up and said, this is awesome. This is how problems should be solved. You don't waste your time solving problems. You solve meta problems. Well, I check in the code, I move on, and then I get this email after a couple of weeks from the client, something terrible has happened in production. And I looked at what happened. I said to them immediately, oh, don't worry about it. I'll fix it right away. And they said, oh, of course we know you will fix it because you are that good. I said, no. I'm going to fix it not because I'm good. I'm going to fix it because I'm the one who caused it. And the problem has blown up in ways I had never, ever thought about. It was a lesson, really a humbling experience to learn this. And what did I do? I reverted back all the change I put in and quietly did the 10 minutes of work that were worked in the first place. And I never heard anything back from them about this problem. And so these days, when I look at a piece of code, the minute I realize it is clever, I delete it. And I start over again because I want a solution that is clear to people. One of the things to keep in mind is, it is not how much time and effort I put in to write the code. I always have to ask the question, how much time and effort other people are going to put in to maintain this code after I leave this code? And a lot of times it could be myself 6 or 7 months from now. And if I'm not able to maintain the code I'm writing today, I have created a lot more liability to the company than I would be worth it. So we really want to reduce that quite a bit. But when it comes to this, here is an example of, in Java, if you look at Java's Enum, literally this is what you're going to look at. It says public abstract class Enum, E extends Enum E. Well, that little noise you heard is your brain throwing an exception. Because you're like, whoa, what does that really mean? And there are very few people in the world who actually understand this code. And even them, they need a quiet room. You put them in a cone of silence, they think very deeply, and they figure this out, do some work with it, and they forget it. So it is extremely complex. And sure, there were good reasons to do this, but that's a representation of complexity right there you're seeing that can be really hard. Now, when I go to companies, a lot of times, employers come to me and say, how do I really obfuscate the code my team is creating? And I often tell them, why do you need an obfuscation tool? Your employees are creating what I call a self-obfuscated code. They themselves don't understand it after they write it. So we don't really have to worry about it. It becomes self-obfuscated very quickly. Now, programmers are very excitable because I know it, I'm pretty excitable, but sometimes we go a little overboard. This is when I firmly believe every code anybody writes, somebody else has to read it. If we don't, it can become a disaster over time. Like this one dude who got really excited about it and has done this coding, and I came across this, and it says float in square root float x. The first problem I have is I don't have a clue what x is. But I got some good news for you. Whatever x is, I have now half of it. And then, of course, if you notice, this is beautiful operations. Don't tell me you don't understand it. You should be smart enough to know this, right? And then what happens? If you say you don't understand it, they put a little comment. What does the comment say? Shifting. And then, of course, it performs this beautiful operation, and then there's something wonderful happens. You received X, and you're returning X back again as an output. Now, when you look at this code, you're scratching your head and saying, what is happening here, and why me? Why am I have to look at this code? And remember how people tell you object-oriented programming represents the real world. You know what? Never trust people who say that. Because it never represents the real world. It represents our abstraction of the real world. But one dude took it too seriously. He was creating flight simulator and said, this is great. The code should represent my line of business, and created that. This is really crazy stuff, isn't it? Now, who is going to maintain this code over time? Not me, definitely, right? So we could get excited, certainly, but this becomes a liability for us to leave when we start doing things like this. So we got to be very careful how we create things. So I said simple is not very clever. Another thing I want to emphasize, very important, because we get into this conversation a lot, is that simple is not necessarily familiar. We get confused between the word familiar and the word simple. Now, what is familiar? Familiar is something you have seen a lot of times, and you don't care to see it again. Familiar is something that is something you're used to, something you're comfortable with. But it is quite possible that something that is very familiar to us is actually pretty darn complex. But because we are so used to it, over time, we have kind of gotten used to the pain. And because we have gotten used to the pain, we don't feel the pain anymore. And then we tend to associate it incorrectly that what is familiar actually is simple. And we have to be very careful about it when we define this actually. So let's think about the word familiar. Familiar is something you have seen a lot, and you may not care to see it again. What comes to my mind is usually my in-laws, right? Yeah, usually in-laws are like that. So you're kind of like, oh, very familiar, but doesn't mean they're simple. And so the point really is that you want to really ask whether it is really, really simple. Let's talk about this. Anybody knows what this one is? Well, we could look at this and say, my gosh, that's a complex set of symbols. But people who speak the language don't think so. In fact, I kind of found out this actually means simple. In fact, it means uncomplicated, casual, and common. How did I know it? I use Google Translate for it, of course. But the point really is that it becomes really complex for people who don't understand it. You know, here's a beautiful country. I've been to this country several times, but I wouldn't say that I am familiar with a lot of things. But it would be really foolish of me to make the claim that things are very complex because I am not familiar. That only will reflect my ignorance if I say that. Exactly the point. When you know that something is very familiar, you get to evaluate whether it's actually simple or complex. But when something is unfamiliar, we have no right to evaluate its simplicity versus complexity because it's unfamiliar, we're ignorant about it, and we first have to get familiar with it before we can even evaluate its simplicity versus complexity. Let's talk about a fairly simple problem here and see how things could really get complex very quickly. You could do this little thing in C# or Java or just about any language. But I'm going to use JavaScript here because it's the most beautiful language, right? So let's talk about JavaScript for a minute. Give it a bunch of names. Print names in uppercase, comma, separated. Well, JavaScript has some really nice features. JavaScript is one of those languages, even before languages like C# did, has been supporting both imperative style of programming and the functional style of programming together. So what do I want to do here? I want to say for, and let's say name of names. Hey, this is great. I got names out of this collection, one name at a time. And what I can do here is I can say process.standardout. Let's say write, and I can write a name.to uppercase, let's say over here. And when I write this little code, you can see the names come up in uppercase. But of course, I want them to be comma separated. So what do? I'm going to say put a little plus, or we could use a fancy, nice features in JavaScript and write the code really nicely. And we can simply say, here you go. And then, of course, I can go ahead and print at this point a little comma around it. So that was not a hard code at all, wasn't it? But when you write this, you suddenly notice there is a stupid comma in the very end. Has anyone seen that problem before? How did you feel the first time you ran into it? You said, this cannot be true. Because it should be such a simple thing to do. Why do I have a stupid comma in the very end? And then you're sitting there without doing your work, trying to figure out a way to get rid of that stupid comma. And you're coming with some very interesting options. Maybe I'll store this into a string, and then I'll remove it. Oh, darn it, string is immutable. OK, I'll store it into a string, and then I'll use the index of to remove it. And then you're thinking, none of this really seems to be right. And then because you don't want to really store it into a string after all, that's not your problem. And then you realize, why did I not think of it? There is a simple solution to do it. Remember the word simple we use in here instead of using the word familiar. So what are you going to do? You say over here, let I equal to 0. How does that go? And then I less than names dot. And now you wonder, is it length or is it size? Is it count? Well, depends on the language, depends on the collection. Somebody calls it length, somebody calls it size, somebody calls it count, because we can never be consistent about these kind of stuff. And then you say length, and then you pause for a second, you ask the question, is it less than or equal to? Because there's no other important business in life than figuring that out, isn't it? And then what do? Once you find that, you say, this is going to be names square bracket I to get the value out of it. And that lingering comma is still around, so you quietly remove that, and then what do? Then you say over here, well, if I is not equal to names.length, then, of course, I want to go ahead and process.standardout over here, and then write, and then I'm going to put the little comma. And the minute you do this, you say, that's not too bad. You realize the comma is still lingering around. You're like, damn it, how do I get rid of this bang, bang, bang? And then you realize, is it -1? And we are kind of nervously trying that. It's like, OK, that works right now. And this works and holds true barely by a very thin thread. Because then your colleague comes to you and says, the rules are changed. Only print the names if they are 4 letters long. This code is going to fall flat. And you're going to say, my goodness, now I've got to put more variables to keep track of which the last one is. and then you're like, I need a coffee break. So this is accidental complexity right there. Very familiar code, no doubt about it, but enormously complex. If you really hate somebody and you don't want to hire them, give these things in the interview and say, this is how your code is, and see them run away from the building, right? Nobody wants to be writing code like this. But on the other hand, we don't have to struggle this hard. You could try this in any language, like I said, but I can say names.map, and given a name, I want to get the name.to uppercase, and then I would simply say, given this collection, just join them, if you will, please, with a little comma in the very end, and you can ask it to do the work without having to struggle through it. Well, most of the languages have been providing an imperative style of programming for a very long time, which really forced programmers to spend more time on imperative style, and as a result, they're not as familiar with a functional style of programming. But it turns out, imperative style of programming, which we are really familiar with, actually is more complex. It is kind of like taking 5 kilos weight and putting on our wrist and then asking it to code all day. It becomes pretty tiring and wears us down, but that's what we've been doing all these years. If you look at the code, on the other hand, the functional style of code, it actually is not familiar to a lot of us, but once we get used to it, we realize it actually has less complexity in it compared to the imperative style of code. So something that's familiar may not actually be simple. It could be actually simple, but may not be. But something that's unfamiliar may actually be really saving us quite a big deal if we get really comfortable with it. And so that is one of the reasons why we should really get comfortable with writing some of these code and getting used to this style of programming. So given this, what we just saw here is that the task may be really familiar, but we should not confuse familiar with simple. We should really ask the question, is the familiarity that's really messing with our mind right now, or is it the simplicity that really shines from this code, and we have to be able to discern from them? So let us not, lots of things are familiar, like, for example, the imperative style, but declarative style and functional style is actually a lot simpler because we tell what to do rather than spending our time and effort telling how to actually do it, which is really a good thing. And simple, one of the key things about simplicity is simple has fewer moving parts in it. We saw this in the code example, even though it's a very simple code example. This is a very consistent theme we see between simplicity versus complexity, is simple code has fewer moving parts in it. Fewer mutable variables, fewer garbage variables, fewer things we have to keep the state in our mind and work to. It becomes a lot easier to work with those things because we have fewer moving parts in the code. Well, I mentioned that simple is not necessarily familiar. I said simple is not really clever. But another thing is, simple is not over-engineered. Now, this is one of the desires for us, the programmers. We want to create beautiful engineered code. And when somebody gives you a problem, you want to exploit the design options in front of you. You want to create an architecture that would scale, and a lot of times we don't know what that scale is. I had a client who come up to me and said, we want you to build this application, but we have 2 requirements, they said. I said, wow, that's great. What are your 2 requirements? And they said, the product should run on the cloud, and it should support concurrency. I said, that's great. And they said, no, we want to make sure you can handle this. It has to be on the cloud, and we really, really need good support for concurrency. I said, can you tell me more about the problem you have? And they said, we don't know enough of the problem, but these are very important to us. So sometimes we kind of decide on the solutions we want, and we quite haven't figured the problem itself that we want to work with. And over-engineering becomes really a liability for us because we can't really maintain the system as time goes on. Rube Goldberg spent his time creating what are called the Rube Goldberg machines. And these were pun intended, but he created these things that would be enormously complex for solving really simple problems. For example, here is an example of a back scratcher that is going to work through a series of combination of activities to scratch the dude's back. Children in schools these days spend time creating Rube Goldberg machines, and it's really a lot of fun to watch this. but they don't realize they get to do this for real when they come to work with us. Because we do Rube Goldberg machines all day at work, isn't it? Well, it reminds me of one experience I had with a developer. I had this project where we were working on, and what this developer had done is there was a data in a database, and he had written about 250 lines of C# code to read this data from the database, and he converts it into an XML representation. So I spend the time reading this code. 250 lines later, I'm like, I understand that he has created this particular format. And then I notice what he is doing. He's sending this XML document to this other function in the same application. And what does this function do? Another 300 lines of code to parse this stuff. And then he takes this data, does a little work with it, and sticks it into the database. And I'm sitting here scratching my head. Here's the data. It goes into XML, and then comes back into data again, and then a little work, and then gets saved. So I was very intrigued by this. So I wanted to really understand what was going on. So I went to the developer and said, enlighten me, please, what's going on here? He said, isn't that cool? I'm like, no, it's not cool. That's why I'm asking you, what are you doing here? Well, I am taking this data, converting to XML, and then receiving the XML. Yeah, I get that. I see what's happening. But why are we doing it? He said, why? Venkat, you need to have a vision. I said, I'm sorry, what vision do I not have right now? Explain to me. Well, he said, the beauty is that data can come from anywhere, and the data can go anywhere now. I said, OK, in our application, where does the data come from? Well, here. Where does it go to? Here. So why are we talking about anywhere? He said, no, you really don't have vision. You should have an architectural vision. While he was saying this, I took my phone and I was dialing. And he said, I'm sorry, give me a second. And he takes the phone and says, hello. I said, hello. He said, is that you, Venkat? I said, yeah. You're right here in front of me. Why are you calling me? I said, you have to have a vision. I could be anywhere in the world now talking to you. I don't have to be in front of you. And the point really is, we have to really understand the problem we are trying to solve. We cannot just throw things together and say, I got to have a vision, because I like shipping products that actually work. And Frederick Brooks said, go ahead and build a software system, and then when you're done with it, throw it away, and you have a better opportunity to build it for what it really serves. So a lot of times, we really want to get it out in the hands of the users, find out if it solves real problems for them, and make the code extensible, but not by building mountains of infrastructure around it. In fact, the very things we put into the code for extensibility is what comes to hurt us the most, because when time comes to really change the feature, the changes are not quite exactly what we had predicted, and all the code and the complexity we built really makes it hard for us to make the change. So a minimalistic solution is actually really pretty good to really focus on. And I'm going to say, simple is not terse. Now, people confuse conciseness with terseness. Concise code is short, easy to understand and work with. Terse code is short, but waiting to hurt us when we least expect. I don't want a terse piece of code. I want a concise piece of code. Well, I came across this example in a client project. And when I was working with them, this particular product sells for a very huge amount of money for licensing. And the developers working on this product are very advanced engineers. And I asked them, do you mind if I take a little photo of this? And they said, OK. And I took a photo of it. Oh, what I really found was not this line, but what I found developers had left right behind it. It said, God help me, I have no idea what this means. So when we program code with such terseness, we lose abstraction. We lose the ability to understand what the code is really supposed to mean. That becomes really hard to maintain the code as well. Well, here's one example. This idea actually came from NUnit, and JUnit kind of copied that idea. And both NUnit and JUnit, what they did initially was, you could write a verbose test like this. So I could say, try and call this max profit after calling set prices. And then I'm checking if the method is actually throwing this exception that I'm expecting it to throw. Well, one of the tools that did the change, first of all, is NUnit. So what NUnit did was, well, if you recollect, C# had attributes way before Java had annotations. So when attributes were around in C# and Unit said, hey, we could be smart about it. And so what they did, the code here is in Java, but you can relate to this in C#. But what they did was they said, we're going to specify the exception at the top. So you probably recognize the syntax in NUnit to do this. And that way, we don't have to have the clutter of all this. And when I looked at this in NUnit, I really screamed because it made me really mad. It's a really bad idea to do it. In fact, the NUnit guys are very smart. They did this and they waited long enough for JUnit to do it. And the minute JUnit did it, they deprecated this and said, this is a bad idea. And so the JUnit has this still holding, and NUnit doesn't do this. They deprecated it, realizing we shouldn't be writing code like this. Well, what's wrong with this? It is a very terse code, I say, because in this case, even if the first method throws an exception, the test will fail for the wrong reasons. I never want a test to fail for a wrong reason. A better way to write it would be probably to use lambdas, and that's what NUnit does today. Oh, by the way, JUnit also does this now, but not as part of JUnit 4, but as part of JUnit 5. This is the way they are moving towards realizing that we don't want the code to be so short that it actually begins to do the wrong things. That's what terseness really leads to. We want the code to be concise and not terse. So don't assume that something that's short is actually better. It could actually be pretty darn evil quite often. So don't confuse terse with simple and concise code. And as Tony Hersh said, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other way is to make it so complicated that there are no obvious deficiencies. So we have to really think about simplicity all the way through. Well, OK, then I mentioned a few things that are really not simple, but you're not going to be satisfied leaving saying, OK, I kind of identify a few things that are not simple, but it would be really nice to actually think about what really are simple. So I'm going to say a few things about maybe we could identify simplicity really well also. Well, the first thing is simple keeps you focused. Now, what is the most precious thing in today's world? The most precious thing in today's world is keeping people's attention. We live in a world of instant gratification. We live in a world of instant messaging and social media. And to be able to sit down and keep the focus and get things done is really not that easy. And when you get down to you writing your code, you don't want your code to help you to lose your focus. You want it to keep your focus. Similarly, the tools around us, the technology around us, should really not make things easy for us to lose focus. And that's very, very precious. And I tell this with all sincerity, because the most valuable thing I have in myself is the time. I can never get it back once I lose it. So anytime anything around me is trying to distract me, I try to get rid of that. So that is one of the most important things when it comes to simplicity. We want to keep our focus. Let's say for a minute, you are programming, and you are not quite sure what method to use for this particular purpose. And you're scratching your head. You're not still clear what method may help you to solve this problem. So you're saying, oh, maybe I should just do a search and look for this method. Maybe I'll do a search that says, how do I really filter out all these values from this collection? So with all honesty, what are you going to do? You're going to do a search. So you are about to maybe open a browser so you can actually do a little search. So let's go ahead and open a little browser and see where it takes us. And I open the browser, and let's see what it says. Oh, wait a minute. Interesting. What a $1 million home can look like in Canada this week. That's pretty interesting. I'm curious how a $1 million home is going to look like. And, oh, iPhone X. Why bother with the iPhone 8? These numbers, they keep switching on us. It's pretty confusing, actually. And then, of course, oh, taxes. You know what? The taxes really suck, I got to tell you. Notice what just happened. I went to search for something, and I completely got hijacked. And this is absolutely not relevant to anything I wanted to do. All I wanted to do was do a simple search, that's all. But all these total noise around me, that doesn't help me in getting my work done at all. Let's try this again. Maybe I can go and search in Bing. Well, that's great. Oh, wait, a beautiful picture. Where did that picture come from? You know what? I'm not sure. I'm feeling I should search for it, but I'm worried that another picture may show up and I may be in a recursion searching for that picture again. let me try this one more time, and I'm going to search, and oh, what do I want to search? Now, think about this for a minute. Now, do you think the developer who designed this had an easy job? Can you just close your eyes and think of the day, the meeting room that morning? The developer is there to do a demo. And he says, I've got the search page ready. And he brings this up, and they look at this and say, hey, what's this? Well, it's a text box. Yeah, I get it. In fact, I know you're going to ask for this, so I even put one button called, are you feeling lucky? Well, you should feel lucky to have this job. And this is courage, isn't it? How many of you in your job will have the courage to say, that's it. I am not going to put any clutter on it. Make no mistake, the minute you hit that button, enormous complexity is behind that button. Huge number of servers and clusters and algorithms and processes are right behind it. But they said, but we're not going to take all that power to waste your time. Because the most important person in this room is you. Your time is the most valuable. And if I distract you from what you need to do, that would be a disservice to you. And this is something I care a lot about when what I do. I want to get people moving. I want them to be focused on what they want to do. I want to make them productive. I don't want to give them anything that they shouldn't care about. But what if I really, really want to know how $1 million house looks in Canada? I'm going to search for that. And I don't want to be distracted with that information. And this is one of the reasons why I'm a huge fan of pair programming. I truly am. One of the terms that I'm really a big fan of is this term called shaving the yak. We all shave the yak. Well, shaving the yak is fun. Totally. I want to have my own time to shave my yaks at least a couple of times a week because it makes me feel really happy. But at the same time, when I'm at work, I also have to keep in mind that I've got production to release. So if I'm alone, what's going to happen? I'm sitting on my machine, I'm doing something, and somebody says, hey, what are you doing? Well, I'm trying to figure this out. I don't know what the call is, and I'm having a little trouble. Can you help me? And Bernie says, yeah, I'll help you with this if you can go help on my machine. And I go look at the problem. I can't figure it out, so I call Sarah and say, Sarah, what's going on here? And Sarah says, oh, I know how to fix this. Why don't you go take a look at my problem? And then a few minutes later, the boss walks into this closet and looks at me and says, Venkat, yeah, what are you doing in the closet shaving this yak? And I'm like, boss, I don't know how I got here. I remember having that problem on my machine. I asked for help, and one thing after the other led me to having to shave this yak. Not quite sure where this yak plays a role in my solution today, but I'm here shaving the yak. We do this all the time. We are solving these meta problems. But imagine you are sitting on your computer, and you are pairing up, and you don't know how to make this call, and what do? You open up your browser, and your browser says, would you like to install an update? And your colleague next to you nudges you and says, not now, dude, we got a problem to solve. And you're like, no, not right now, and keeps your focus on it. I have to tell you, I've never seen a pair of programmers sitting in the closet and shaving a single yak. So that's actually a good thing in general. So we want to really keep focus, and focus is extremely important. So anything we can do to keep it. So simple keeps you really focused, and that's one of the beautiful things. And here's a code that I really like a lot. And this code says, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And this is the thing that I constantly remind myself when I do design. It's not what I can add that matters. It is what I can remove that really matters. I use this not only when I do software design, I do this when I write books, when I write articles. The words are golden. You want to really minimize the words you use and deliver the content really concisely so people can actually understand it without a lot of fluff and words that would distract them and waste their time. So taking things away is a very important skill we have to create for keeping things really simple. So simple eliminates accidental complexity and hides the inherent complexity. Now, the inherent complexity is based on the problem domain that we are working with. The application carries complexity with it. But when we use a wrong solution, the solution brings on more complexity, and that becomes a vicious cycle because we bring more solutions to solve those complexity, and we get dragged into it. So I want to minimize as much as possible accidental complexity so I can more prudently deal with the inherent complexity of applications. The next thing I want to emphasize about simplicity is simple keeps your focus, but simple also fails less. Now, when programs begin to fail, how annoying it is for the user. I'll give you an example of this. They asked me to fill an application for a visa. And I started filling the application for the visa. Then I came to this section where it said, list all the countries you have visited in the past 5 years. I'm like, are you kidding me? And that took me hours to enter because I travel almost every week around the world. And I have to sit there and enter everything. But as I was entering it onto this website, my programmer mind comes in and keeps telling me, dude, do you understand you're using an application? A user mind says, enter the data. Programmer mind says, this is going to crash. This is going to crash. So I started copying and pasting literally every information into a text file as I entered into this visa site. And I came to the last page, and I clicked on the submit, and the whole damn thing just disappears. And I'm like, thank you very much. And how do you feel when applications behave like this, and you wipe your sweat and say, I'm going to start over again? At least I copied this on the text file. Now I had to just copy and paste it. And of course, you say, are you stupid to try it again? Well, that's called desperation. I still wanted to travel to that country. And about the third time, it actually worked. So it's wonderful when things work like that. But the point really is, you should really make applications fail less, and if they do fail, they should fail gracefully. Same thing with APIs, same thing with libraries we use. We want to fail less. But failure is not just the runtime behavior. It should make us fail less as well in our attempt to use these libraries too. What if a library is so obvious to you how you would actually use it? I'll give you an example of this. I was working very late one night, and by this time I was very, very sleepy. I was barely awake. And maybe you would say, Venkat, this is not a good time for you to drive. But I really had to get home, so I was driving. And that's when I realized my gas is low on my car. So what did I do? I pulled up to the gas station, and I wanted to fill up gas. And I could barely, I have no attention span right now. And I pull up, I put my credit card, and I take this pump and the nozzle, and I'm trying to insert it into my car, and it just would not insert. And I'm almost at the point where I want to cry. I'm like, why do this to me? I'm really tired. I want to go home. I want to sleep. Why would filling a gas in a car be such a hard task? And it wouldn't work. And that's when I said, stop, Venkat, think. And that's when I realized it's actually diesel nozzle, and I can't put that where petrol belongs. And I'm like, thank you for designing it this way, right? And imagine they had not done this. I would have filled diesel on my car, and I don't think I want to get a new car. That's not the way to get new cars. So that's an example of where things actually fail less, where it can protect you from making these kinds of mistakes. That is something we should really try. Now, look at this example here. This is the manhole, and of course, you see that little round circular lid. And I could ask you, why is this lid circular in size? And most of you probably will strike with an answer very quickly. You would say, oh, of course, the reason why this is a circle in shape is it will not fall into the hole. You are not wrong. You are correct. But imagine for a minute, you are going to send a proposal. You could even try this. Send a proposal. And you tell the proposal, your proposal says, we want you to build a cover for the manhole. And when you build the cover should not fall in. And I bet you very few proposal replies you get back will be a circle. Because that is so simple. And we cannot charge you more if I make things very simple, right? So what would you get back most likely? It turns out each of these shapes also have that property. You cannot put any of these inside also. And the chances are, if you're dealing with business contractors, they're going to send you one of these, not the circle, because they can charge you more for these things, right? And it looks cool. But circle has one other property then, it won't fall in. If you are this person coming out, your team is waiting there after a very long day's work, and when you come out of this hole, you turn around and you ask the team, hey, dude, which way do I put this? And the answer is, roll the damn thing over, let's go home. And that is one of the most beautiful things about the solution, too. It's not that it won't fall in. It doesn't matter what direction you put in. It is the absolute ease of use that is incredibly powerful here that we should really think about. There's no wrong way to do this. That's the whole point. So when it comes to this, simple is easier to understand, and simpler is easier to work with as well. What if we start designing our libraries in a way the person using our library doesn't have to feel the pain? How many times have you used a library where you look at the method, and the method says the parameters are 3 parameters, and they are int p1, comma, int p2, comma, int p3. And you look at this and say, why are you hurting me, right? Because you don't know what these 3 ints mean. You don't know what order to send them in, and they are making us work too hard to figure this out. Not very simple at all. Well, here's an example. I wanted to find if a number is a prime number. Well, to do this, what I could do is I could write a code like this. I could say is prime, which tells me whether a number is prime. But here is a primes, which is going to return. It's going to say if a given number is prime, concatenate that with the value and all the primes that follow it. Otherwise, return to me just all the primes that follow it. Unfortunately, this code won't work. And the reason this code won't work is it'll go into an infinite recursion and throw a Stack Overflow exception. But it turns out we can actually do this. You can do this in CSharp as much as in Java by using infinite streams. And in the case of CSharp, you can use an iterator to get an infinite stream. And you can say, given these values lazily being created, I can produce these kinds of results, and I can produce it. By looking at a slightly different solutions, we can start finding good solutions to problems. But is this really a complex solution, or is it a solution that's simply not familiar to us, comes into a question. So sometimes when we explore these ideas, we have to really work really hard to find a elegant solution. And simple is elegant. So let's think about elegance for a minute. You know, why is this one of the most beautiful paintings ever created? And I would argue the reason this is the most beautiful painting ever is because of the simplicity in it. It is what? There is nothing here. There is this lady, and there's not a whole lot around. That is pure elegance, pure beauty, and that's what you're really looking at. There is no ornaments to clutter. There is no things to clutter. There is absolute simplicity, and elegance comes out of that. Simplicity comes out of this elegance. And so we want to be able to create something. But I was fascinated by this quite a bit, and I call this the architect's dilemma. So I was visiting Boston, and I was walking through the downtown with my family, actually, and I was visiting. I came across this Trinity Church in downtown Boston. And when I looked at this Trinity Church, I actually did not look at the church directly, but I was looking at the church, and I stood there absolutely mesmerized. In fact, I refused to move. I just was stuck over there with my camera trying to take photo until my family eventually came and said, you better start walking or I'm going to call the cops. And so why was I so thrilled about it? What really helped me there? What really helped me there was not the church, actually, but next to the church, there is this John Hancock Tower. Well, they wanted to build a tower in downtown Boston, and they applied for a city permit to build this high-rise next to this church. And the city said, there's no way we're going to give you a permit to build a building next to this particular church, because when you build this, the beauty of the church is going to be destroyed, so we will not allow you to build this over here. The architect came around and said, no, we do want to build here, and when we are done with this building, the church, will look even more beautiful, he said. And they kind of entertained the thought, and they said, okay, let's try. And so what he had actually done is actually this. he created this building next to it in such an angle that the reflection of the church is a lot more beautiful, at least to my eyes, than the church itself. And the camera here is not doing a good justice for you, but if you ever get a chance to go to Boston downtown, I encourage you to take a look at it. It is just unbelievably beautiful, and you can just stand there and stare at the church through the reflection on this building at the angle in which it is, and the pure elegance, the solution that was here to bring the beauty of this place is just unbelievable. And this is something that I admired quite a lot. A lot of other things were exciting, but I kind of stood there just admiring this architectural work, and that is a really, really simple solution for a problem to bring out the elegance, as you can see in this particular case. But I've also realized, though, while we all want elegant solution, very few of us can actually create elegant solution in one sitting. In fact, elegance has to really grow and evolve. We have to work towards making things really elegant. And Feynman said, if you cannot explain something to a first-year student, then you haven't really understood it. This is one of the things I use to measure whether I know some stuff or not. I remember teaching a class way back in time, and I went to the class. I spent an hour lecturing on this topic. And when I finished lecturing, I found that everybody was, in their face, I could see the pain in them. And because no one in the class got it. I didn't even pretend to ask them, do you understand? Because I know they didn't understand it. So I said, you know what? Count this as a failure. Never mind. I'll see you guys tomorrow in class. And I went away. And I came back the next day, and I explained it. And within 30 minutes, people came to me and said, oh my goodness, this is so easy to understand. And by the way, why did you have so much trouble explaining this on Monday? What was the reason? I said, oh, there's a very simple reason. Because when I explained to you on Monday, now I figured out I did not understand it. And when I tried so much to explain it, and when I went back that night, I realized I don't really understand this after all. I was trying to teach this stuff. And when I sat there for 3 hours that night and trying to go over it, it finally clicked in, and I got a deeper understanding than I ever did. So it was much easier for me to explain. And that is one of the most beautiful things is when you understand something really, really well, it becomes easier for helping others to learn it. Otherwise, it becomes really, really hard to understand it. And this is something that kind of comes back and forth in my experience. Occams Razor says if you have two solutions which are equally useful for a problem, then choose the simplest of those solutions. I learned an experience when I was writing the book on Java 8. I was working on this book when Java 8 was being developed, and what I really wanted to do was show that we can implement tail call optimization. I mean, there's this inner spirit in each of us to do something kind of little weird and unique. I want to do a tail call optimization. So here is a factorial, as you can see, where I'm calling the factorial method recursively, but unfortunately, this will end into a Stack Overflow. But a tail call will not have this kind of problem. Well, I've read books like Structured Interpretation of Computer Programs. And in this book, they talk about something really phenomenal. They talk about a difference between process and procedure. A procedure is a code you write. A process is the runtime of that procedure, where what runs in reality. When you write a loop, you're writing an iterative procedure. It runs as an iterative process. When you write a recursion, you're writing it as a recursive procedure, and it runs as a recursive process, no surprise about it. But in tail call optimization, what you can do is you write it as a recursive procedure, but it can run as an iterative process. Then you will never get a Stack Overflow exception. I've seen how this is being done in languages like Clojure, in languages like Scala and Groovy and Haskell and Erlang. So I know that these languages do this. But Java itself does not have tail call optimization. So I wanted to really implement it. And so I literally wasted 2 full days of my life not doing anything but trying to create a tail call optimization solution. And when I created a solution, it looked somewhat like this. And I then spent 10 more hours, and I wrote something like this. And the real essence of this is a while current.apply is equal to current, then execute the current. Just look at this part alone. It'll become really easy to see. All the other things are not important. So current.apply is set to current, and then current.is complete, and I keep repeatedly calling this method. Well, this is the solution I had after about 2.5 days, maybe 3 days of effort. And that really bothered me. And the reason it bothered me is when I was writing this book, until the previous page in the book, I kept telling the programmers, avoid mutability, avoid mutability, avoid mutability. And then when I wrote this example, what am I doing? Mutating. So I spent countless hours on this, and in all honesty, I was totally lost. Then I came up with a brilliant, brilliant solution. I still think it's brilliant. Because what I decided to do was, right under this example, I wrote a paragraph. And the paragraph said, dear reader, do you notice I'm using mutability to solve this problem? The solution with no mutability is left as an exercise to the reader. Because that was a brilliant solution, wasn't it? It would have worked about 30 years ago. But today we live in the world of Twitter and Facebook. And the minute the book comes out, they're going to say, oh, yeah? So why don't you post the solution, damn you? And so that's not going to help. So I said, OK, let me rethink about this. And I spent a little bit more time, and I said, OK, a better solution. Well, don't use mutability except in cases where you cannot avoid it. And I felt really silly about it, too. And I said to myself, I came to a grim realization, but sometimes it's good to come to this kind of realization. I fully realized my code simply sucks. And I said, there's no way I'm going to put this out, so never mind. And I kind of moved on. And a few days, 2 or 3 days later, I was on the treadmill exercising, and slowly in the back of my mind, a thread is processing this problem. And suddenly, I'm like, whoa, wait a minute. I totally didn't realize I could do this. And I jumped into the treadmill, ran 2 floors of my building, while my children screamed, are you OK, Daddy? I'm like, yeah, I found it. And in 15 minutes, I had a solution. And the realization came from something I never expected. I realized that in the primes example I showed you, we can use an infinite stream, meaning I can create an infinite collection. Well, what if the collection was not numbers or other data objects? What if the collection was, every object in the collection was a function? And because it's an infinite series, when you evaluate one function, you get to decide if there is more functions or not. And the minute I realized that you could do this, 15 minutes later, I had a solution which really avoided mutability and became really elegant. I said, given a function, iterate over a collection of functions, and until it's complete, but find first and get me the first one and print the result. You know, in CSharp also, for example, you have this ability for getting the find first. I think it's also called as find first or default. You could also use, and those are lazily evaluated. So that becomes really easy to implement that kind of solution, something I never actually thought about, but came to be really useful. And sometimes it takes a very long time to find solutions that are actually simple. And so as Einstein says, everything should be made simple as possible, but not any simpler. But it always worries me, is what I created simple, or can it be even more simpler? And I always learn by getting feedback from other people, because when I show something to somebody and I think it's simple, they come back to show me that there could be actually something even more simpler. While it's very humbling, it's also very important for us to improve and build something simpler as well. So I have this feeling that maybe simplicity is that Schrodinger's cat. When you look at simplicity, what you have is simple, and yet it is complex at the same time, until somebody can show you that there is maybe something a lot more simpler than what you thought about. So simple makes things easy, but it certainly is not easy to create something simple. It usually comes from hours of toiling, hours of rethinking, hours of challenging, and hours of having the courage to delete what we have created and then recreate it. And I think that is extremely important. So I'll leave you with this thought by Da Vinci, and I think it plays really well. He says, simplicity is the ultimate sophistication in life, and that is absolutely true. And I think it's worth striving for it. And the more we attempt it, the more we do it, the more we practice, I think we develop a knack for creating things simple. And I think that's very well worth doing it time over and again. Hope that was useful. Thank you.